The NEC Engineering and Construction Contract provides a range of main options. These options primarily define the payment method for the contractor. They also determine the distribution of risk between the involved parties. A clear understanding of these options is essential for successful project management. NEC contracts include main options and core clauses. Main options can vary across different NEC contracts. Core clauses provide a foundation of standardized practices. Core clauses remain consistent regardless of the main option selected. This consistency ensures a baseline level of uniformity across all NEC contracts. The NEC ECC Engineering and Construction Contract offers 6 main options for project management. These options are designated as Option A, Option B, Option C, Option D, Option E, and Option F. Each option is specifically designed to suit different project requirements and contexts. The selection of an appropriate option is crucial for effective project execution. Careful consideration of project needs ensures the chosen option aligns with project goals. Understanding the nuances of each option is vital for successful project outcomes. Option A is defined as a price contract. This contract includes a predefined activity schedule. It operates similarly to a lump sum contract in its payment structure. The contractor receives payment upon the successful completion of specified activities. Therefore, payment is directly linked to tangible progress within the project. Option A involves a pricing structure where the final cost is largely predetermined. This fixed pricing model means the contractor bears the majority of the financial risk. The contractor is responsible for managing costs within the agreed-upon price. Any unforeseen expenses or overruns directly impact the contractor's profit margin. Therefore, Option A transfers most of the financial uncertainty from the client to the contractor. Option A is most appropriate for projects where the scope is clearly defined. It is suitable when minimal changes are expected throughout the project lifecycle. An example scenario is a warehouse project with complete IFC drawings. The presence of complete IFC drawings indicates a well-defined project scope. Option A involves a payment structure based on activity completion. The contractor initially provides an activity schedule. This schedule outlines the various tasks and their expected completion timeline. Payment is dispersed as each scheduled activity is successfully finished. The contractor receives funds specifically for completed activities. This method ensures payment is directly tied to tangible progress on the project. Errors in the activity schedule are fundamentally the contractor's responsibility. The contractor bears the risk associated with any inaccuracies or omissions. Compensation events are not evaluated using activity schedule rates. This means the schedule's pricing does not dictate compensation for unforeseen issues. Financial adjustments for compensation events are determined independently of the activity schedule. Option B represents a price contract that includes a bill of quantities. This type of contract operates as a remeasurement agreement. The contractor receives payment based on the actual quantities of work installed. Payment directly corresponds to the measured and verified quantities of completed tasks. Option B involves payment based on remeasured quantities. Under Option B, quantity risk primarily resides with the client. The client bears the risk of discrepancies between estimated and actual quantities. This means the final payment could vary depending on the remeasured quantities. The client's financial exposure is directly linked to the accuracy of quantity estimations. Careful quantity surveying and validation are crucial for the client to mitigate this risk. Option B is suitable for projects with a well-defined design. This option is particularly useful when project quantities are uncertain. Roadworks, where excavation quantities can vary, are a good example. The defined design provides a framework despite quantity uncertainties. Option B involves payment to the contractor based on actual quantities installed. The payment is directly tied to the amount of work completed. Installed quantities are determined through remeasurement processes. Remeasurement ensures accurate assessment of the work performed. The contractor receives compensation proportional to the verified installed quantity. Errors occurring in the bill of quantities are classified as compensation events. This classification has significant implications for project cost management. Specifically, errors trigger adjustments to the contract sum to account for the discrepancy. Due to this, the accuracy of rates becomes more important than initial quantity estimates. Correct rates ensure fair compensation when quantity errors necessitate adjustments. Option C represents a target contract. This contract includes a detailed activity schedule. Both the client and contractor agree upon a target price. Cost deviations from the target price are shared between the parties. This shared risk encourages cost control. The activity schedule provides a structured framework for project execution and monitoring. Option C employs a gain-share mechanism. This mechanism involves both the client and the contractor. Both parties share in either savings or losses. The sharing is relative to a predetermined target price. If costs are below the target, both parties benefit. Conversely, if costs exceed the target, both parties incur losses. Option C is most appropriate for intricate projects. These projects often necessitate robust collaborative efforts. Major infrastructure projects exemplify this need for collaboration. Such projects typically involve designs that are subject to change. The evolving nature of the design demands flexible teamwork. Option C facilitates the required level of collaboration for these dynamic projects. Option C involves a payment structure where both parties share financial outcomes. A target cost is established as a benchmark for the project or service. If the final cost is lower than the agreed-upon target, savings are shared between the parties. This incentivizes both parties to find efficiencies and reduce expenses. Conversely, if the final cost exceeds the target, both parties share the increased expenses. This shared risk motivates collaborative cost management and budget adherence. Option C prioritizes the implementation of early warning systems. A key focus is maintaining and enhancing the quality of programs. Collaborative decision-making is a central tenet of Option C. These elements collectively define the core behavioral characteristics of Option C. Option D represents a target contract. It utilizes a bill of quantities for pricing. This option is similar to Option C in structure. Remeasurement of quantities remains applicable. The target cost is constructed from the bill of quantities. This allows for adjustments based on actual work performed. Option D is particularly well suited for infrastructure projects. These projects often involve uncertain quantities of materials or work. Collaboration between stakeholders is essential for successful execution. Rail projects can benefit from Option D due to their evolving requirements. Highway projects, similarly, can leverage Option D for quantity adjustments. Option D's flexibility accommodates the dynamic nature of these infrastructure works. A cost-reimbursable contract involves the client reimbursing the contractor for defined costs. In addition to cost reimbursement, the contractor receives a pre-negotiated fee. This fee represents the contractor's profit margin or compensation for services. Under this arrangement, the client bears the majority of the financial risk. The client is responsible for covering the actual costs incurred by the contractor. Cost-reimbursable contracts are suitable when project scope is uncertain. Option E represents a specific contractual agreement. Under Option E, the contractor assumes minimal cost risk. This arrangement shifts the majority of financial risk to the client. The client is therefore responsible for most potential cost overruns. This risk allocation should be carefully considered during contract negotiation. Option E is particularly well suited for emergency work scenarios. It is also applicable to projects with scopes that are not clearly defined at the outset. A prime example is emergency flood repairs. These situations often demand immediate action to mitigate damage. The urgency leaves little time for detailed planning or scope definition. Option E allows for flexibility and rapid response in such circumstances. Risk transfer strategies involve shifting risk between parties. The spectrum ranges from the contractor bearing the most risk, Option A, to the client assuming the majority of the risk, Option F. Options B, C, D, and E represent intermediate risk-sharing arrangements. Each option reflects a different allocation of responsibilities and potential liabilities. Selecting the appropriate NEC, New Engineering Contract option, is crucial for project success. The optimal NEC option hinges on factors like design certainty and risk tolerance. Project complexity also plays a significant role in determining the right NEC choice. A key consideration is balancing the need for project speed with the desire for cost certainty. An incorrect NEC selection can result in disputes, increased costs, and project delays.